Okay guys, in today's video I want to go over USB operation and talk about how different it is than RS-232 and Ethernet, and give you a few more tools that you can use to look at it so you're just not helpless when it comes to its operation and what it's doing. One of the first things I want to go over is, and everything we're going to be talking about is USB 2.0 or lower. I'm not going to get into 3.0. You can do that for another video, but USB has a definite host-client relationship where you're one role or the other. And if you're a host, you can't talk to another host. And if you're a client, you can't talk to another client. And that's something you kind of got to figure out right away. Well, which role am I doing? You know, what exactly is this device in the middle of? And to recognize the key differences is that the host does start everything, and the device only talks when spoken to. That's and that the host provides the power, and that's kind of how you can differentiate between the two of them. But normal USB here, we're dealing with just the four wires. We have the power wires of negative and plus 5 volts, and then the two data lines here. When you first plug in the device into a host, there is an electrical way that they know that something has plugged in, and they do a little training, chirping to establish the speed that they're going to talk to each other, very similar to other devices like Ethernet. And once they have their speed established and there's connection, then the host requests the client to send it its information, and that process of connecting and sending the information is called enumeration. And this is where this really gets really different from RS-232 with at this point, because these devices can do so many different things. The operating system needs to know what kind of USB it is. So it basically asks it to describe itself, and depending on what it describes, it looks in its own database to see if there's a driver file that will allow it to configure itself to match what the USB is going to be putting out. And if it can't find an exact match, if it's in a class that it recognizes, it can use a generic driver. And if it's something that's just completely weird to it, it'll say I can't do anything with it, and it'll error it out and not activate it. But once it's got its driver installed, then it can start going about doing its job. Now, this is the most difficult thing to get a hold of with USB sticks is that because they're only using 2 wires, and they're definitely half duplex, which means they can either transmit or receive, but they can't do it at the same time. They have a setup to where, depending on what kind of things they're doing, they can have multiple virtual spots in the device that communicate with the program in the host, and they don't want to try and do the multiplexing all on one and then leave it to where you have to have some kind of brain in the device to figure out how to send it back to its individual components. They just address each one of these data lines with a different number to get it to its appropriate thing. And let me kind of describe how this works with a simple webcam. What we have here is, on a webcam, we have 4 different things going on. I got each mouse here doing a different job. We have the bus driver up front here, and it's at what's called an endpoint, which basically means it's an individual data destination. And all USB devices have an endpoint 0, and their job is to talk to the USB host controller and to take instructions from it, and to give it its description, and to describe all the different things that it's doing and how many different pipes that it's going to need, how many different connections to the system that the applications on the other side will be expecting it to have. And they'll know how many of these pipes that they're expected to have by the driver configurations. And that's what will communicate to all the people on board that, hey, when we see this particular webcam, it's going to have 3 different control or data pipes. One is going to be to take the audio from the webcam into the system. The other one is going to be take the video from the webcam into the system. And the third will be to do the controlling of the webcam functions from the system as well. Now, each one of these virtual pipes will end up in a little data buffer that any of the apps that are in the machine that have the security permission to use the webcam can come over here and get the data that they want, video or audio or whatever it is that they're going to want from this device. And this is how it runs these devices with multiple functions. So, and they're doing it all through the complete control of the USB host controller over here. So now when we most everybody who's ever done anything with USB, they pretty much have always defaulted over here to the device manager. And sure enough, when you come over here and look at the device manager, you'll see some USB things, and you won't get hardly any information from them. But they'll hide the other USB devices if they end up doing some other function, like over here. Like there's a Bluetooth USB device, but it doesn't even show it. Right now I have it disabled because I want to put an alarm on it to show you this other thing. But this was very frustrating when you have a unknown USB device and you go and plug it in, and device manager does its dunk thing, and you come back and you look, and nothing changed on the USB. So you know it had to be something up here somewhere. You have no idea where it got put. So this is horrible. Now, when you come over here, when you do a search for, is there anything better than this? Microsoft came up with a program called USB Device Viewer, and this is in its the web developers toolkit. And it was a much bigger improvement over the device manager. At least in this one, you have a way of seeing these devices, even the ones that are doing some other job, and you can get a lot more information about what's going on with them than just the pitiful little information the other one has. But this one had a lot of limitations, and they kind of just, I don't know, I think they gave up on it. And some guy from Germany came in, and he just basically took it, and I'm surprised they never sued him for copyright, but he basically just took their program and because it looks almost exactly the same when you compare them side by side. But he took their program and just totally improved it, and he made everything that was good about the other one and then some. So now when you come over to this program, you get so much more information about what's going on. For instance, I can come over here and it says device has problem code 22, device is disabled. And it shows, like I said up here, I got a COM4 serial bridge and all these other things. And when you're looking at these in the parentheses where it's talking about 2EP, this is how many endpoints that it has, what we were talking about before. But anyway, this is the program you want to get and you want to have available to you, because this one's really going to show you what's going on with your device and not have any doubt about what's going on and what exactly the where my drivers, which driver I'm using, where it's located, all these kind of things. So anyway, I highly recommend, like I said, this USB device tree viewer. I'm going to put the link in the bottom. And now what I wanted to do is I just wanted to pull up WireShark and give a demonstration of the enumeration. When I plug in, I'm going to just be plugging in a keyboard, and we'll have a look at the sequence of packets that go back and forth when you initially plug in a device like that. So stand by for that. Okay, I got WireShark up. I'm going to go ahead and start the capture on the USB port and plug in the keyboard, and then I'll freeze from there. So stand by. Okay, I was able to do the capture. It starts at 1596 and ends at 1630 here. So see if I can find it. Here we go. And so it took, like I said, 1630. So a total of 34 packets to get this in. And so you can. This is like I said, the keyboard calling in to get its. And it looks like the keyboard's going to be given an official number of 1.8.0, and it's given itself. It's a Darfon Electronics Corp, and that's what it is. Anyway. And if we come over here and look at the keyboard, you can see it's a Darfon wired keyboard. But yeah, so with WireShark, it flies by super fast. So you got to have very limited USB things in, or you have to come back and sort and source after. So kind of keep an idea of where the time that all the activity was going. But this is another way that you can actually see the back and forth that goes on when you plug in a USB cable and when it's working. So, all right, well, I hope this helps and at least demystify some of the USB magic, and we'll talk to you soon.